Everyone. Today we will going to see some practice questions from the chapter Coordination Compound. This is part 1. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any of images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. This is our index slide. Today we will going to see some practice questions from question number 1 to question number 8. Let's start with the question number 1. If excess of AgNO3 is added to 100 ml of a 0.024 molar solution of dichlorobis ethylene diamine, which is cobalt third chloride, how many moles of AgCl be precipitated? So we have given that the AgNO3 amount, excess amount, is added to this a solution of dichlorobis cobalt third chloride, who has a molarity of 0.024 and the solution is 100 milliliter. We have to find out that how many moles of AgCl will be precipitated at the end of the reaction or process. Options are 0.0012, 0.0016, 0.0024 or 0.0048. You have 10 seconds to solve this question. After that, we will see the answer. Okay. Now, let's see. The correct answer is option C, that is 0.0024. We have given that 100 milliliter of 0.024 molar solution is equals to 0.0024 mole of the complex, right? We have given the volume and the molarity. We can find out the number of moles of the complex by multiplying the molarity into the volume, which is basically equal to 0.0024 moles of the complex. Now, the complex is cobalt dichlorobis ethylene diamine cobalt third chloride, right? This is the formula of that complex. And thus you can see that one chlorine ion is formed per mole of the complex, because as in the formula given, one chloride is out of the square bracket. That means out of the complex. So if you dissociate this complex, only this one chlorine will be dissociating as ion, and the whole complex inside the square bracket will remain as it is, and some plus one charge will come on this square bracket, right? So one chlorine negative is formed per mole of the complex, which gives 1 mole of AgCl, because we have asked that how many moles of AgCl be precipitated. Okay, so the complex is giving us 1 chloride ion, right? That means we will get 1 mole of AgCl. Now the moles of AgCl precipitated will be 0.0024, because the total moles of the complex is equals to 0.0024, right? Basically what we have done, we just find the number of moles of the complex, okay, just by multiplying the molarity with the volume. And we see that the complex has 1 chloride ion outside of the square bracket, outside of the complex pair. Then this chloride ion will dissociate as one ion, and this whole square bracket compound or complex will dissociate as another ion, right? So you can see that 1 mole of chloride ion will dissociate and will give 1 mole of AgCl precipitate as a precipitate. So the total moles of AgCl precipitated in this case is 0.0024 mole, because this number of mole is going to be have of the complex, right? And that is how our answer will be 0.0024 mole. and thus option C is the correct answer. Let's move to the next question. Question number 2. Consider the following complexes: K2PtCl6, platinum Cl4.2NH3, platinum Cl4.3NH3, platinum Cl4.5NH3. Their respective electrical conductances in aqueous solutions are. So what we have to find out that what will be the conductances of these complexes in the aqueous solution. Options are 256, 0, 97, 404, 404, 0, 97, 256, 256, 97, 0, 404, or 404, 97, 256, 0. You have to select the correct electrical conductances for the following given complexes in the question. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option A, that is 256, 0, 97, 404. We use this concept here that greater the number of ions produced, greater will be the conductance. They are directly related. So we check in all the given complexes how many number of ions is going to produce after dissociation. In the first, K2 platinum Cl6, this is the formula of the complex. It will produce 2K positive plus platinum Cl6 2 negative. Okay, so you can see that we have 3 ions producing after dissociation, right? So because 2K positive and 1 this complex ion, so 3 ions is the total amount. In the second case, platinum Cl4.2NH3, platinum NH3 whole twice, Cl4. This is the formula of the complex. And you can see that no ions is producing in this case. That means it is the least number of ions which is producing in this 4 complexes. Okay, that's why this is the least number. No ions is producing. In the third case, platinum Cl4.3NH3, right? The formula for this will be platinum NH3 whole thrice Cl3 and 1 chlorine will come out of this square bracket, right? Because the coordination from the platinum can have only 6 number of direct bonds to the ligands. That's why it is completing its valency by attaching ammonia, 3 ammonia molecule and 3 chloride ions to itself. So 1 chloride ion will be remain at outside of the square bracket. Now if you dissociate this, it will dissociate in this manner. You can see 2 ions producing, 1 Cl negative and 1 this square bracket whole positive. Now in the fourth case, platinum NH3 whole 5 Cl and Cl3 outside. Okay. In this case, you can also see if you dissociate it, it will produce this this square bracket 3 positive plus 3 Cl negative. So total 4 ions, 3 here and 1 here. So 4 ions, that is maximum in these 4 ions. The maximum in these 4 complexes, we have the fourth number of complex producing the maximum number of ions after dissociation, that is 4. And what we have said that greater the number of ions produced, greater the conductance. So we just arrange according to this concept and match the options. So the highest conductances will be for the fourth one. So it is 404. Then the first complex will come, which is 3 ions producing, so 256. Then 2 ions, which is produced by the third complex, that is 97. And then least or no ions is producing by second complex, so 0 will be its conductance. And this is the correct conductance or the value of electrical conductances of the given complexes in the question, right? Thus, option A is the correct answer. Okay, let's see the next question. Question number 3. A solution containing 2.675 gram of CuCl3.6NH3, molar mass is given as 267.5 gram per mole, is passed through a cation exchanger. The chloride ions obtained in solution were treated with excess of AgNO3 to give 4.78 gram of AgCl, having a molar mass of 143.5 gram per mole. The formula of the complex is, we have to find out the formula. We have given atomic mass of silver, which is 108 unit. Options are cobalt NH3 whole 6 Cl3, cobalt Cl2 NH3 whole 4 Cl, cobalt Cl3 NH3 whole thrice, or cobalt Cl NH3 whole 5 Cl2. You have 10 seconds to solve this question. After that, we will see the answer. Let's see. The correct answer is option A, that is CONH3 whole Cl3. So first we will calculate the moles of COCl3.6NH3, which is given mass upon the molar mass. Both are given in the question. We just divide them. So it is coming out as 0.01 mole. Now this is the reaction happening. AgNO3 plus chlorine giving us the precipitate of AgCl, which is white in color, plus NO3 negative ion. Okay. Now moles of AgCl will be equal to given mass upon molar mass again. So it is 0.03 mole. So what you can observe that 0.01 mole of COCl3.6NH3 giving us 0.03 mole of AgCl, right? Therefore, 1 mole of COCl3.6NH3 ionized to give 3 mole of chlorine or chloride negative, right? We just relate both the terms and calculate. Hence, we can see that 3 moles of chlorine ion will be going to produce while dissociating. That means 3 chlorine atoms should be attached at outside of the square bracket in the complex, right? So we can say, hence the formula of the compound is cobalt NH3 whole 6 and Cl3. This Cl3 should be outside of the square bracket to be dissociated as 3 mole of chloride ion, right? And thus option A is the correct answer. Okay, let's move to the next question. Question number 4. On treatment of 100 ml of 0.1 molar solution of COCl3.6H2O with excess of AgNO3, 1.2 times 10 to the power 22 ions are precipitated. The complex is, we have to find out the complex. We have given some information that we have a solution of this COCl3.6H2 which we have treated with excess of AgNO3 and we get this much amount of ions. So what will be the complex? Options are cobalt H2O whole 4 Cl2 Cl.2H2O, cobalt H2O whole thrice Cl3.3H2O, cobalt H2O whole 6 Cl3, cobalt H2O whole 5 Cl2.H2. You have 10 seconds to solve this question. After that, you will see the answer. Let's see. The correct answer is option D, that is cobalt H2O whole 5 Cl square bracket close Cl2.H2. So what we will do, we will find the molarity, which is number of moles of solute upon volume of solution in liter. So number of moles of the complex will be volume times molarity. If volume is in milliliter, we have to divide it by 1000. Just put the values. Molarity is given as 0.1. Volume is given as 100 milliliter. Divide by 1000. It is 0.01 mole of the complex. Now, the number of moles of ions which is precipitating, will be the given number of ions divided by the Avogadro's number. That means total ions. So it will be 0.02 mole. The number of moles of ions precipitate will be 0.02 mole, and we have the number of moles of complex. We have to find out the complex, right? So what we will do, we see that the number of chloride ion present in ionization sphere will be number of moles of ions precipitated divided by number of moles of complex. So ions precipitated is 0.02 divided by 0.01, which is number of moles of complex. On dividing it, it is coming out as 2. So you can say that 2 chloride ions are present outside the square brackets. That's why we are getting, after dissociation, 2 moles of chloride ions, right? So the formula of complex we can write after looking at the options will be cobalt H2O whole 5 chlorine Cl2 dot H2. Okay, and thus the D option is the correct answer. Okay, now let's move to the next question. Question number 5. The coordination number and the oxidation state of element E in the complex En whole twice C2O4 NO2 are respectively, where En is ethylene diamine. What we have to tell coordination number and oxidation state of element E. Options are 6 and 2, 4 and 2, 4 and 3, or 6 and 3. You have 10 seconds to solve this question. After that, we will see the answer. Let's see. The correct answer is option D, that is 6 and 3. So this is the ethylene diamine CH2 NH2 whole twice, which is a bidentate ligand. And the oxalate, that is C2O4 2 negative, is also a bidentate ligand. Hence, you can say that the coordination number of E will be 6. How? The C2O4 oxalate is a bidentate. So it is directly attaching with 2 bonds. So 2 here. Ethylene diamine is also a bidentate, and the two number of ligands is present of ethylene diamine. So 2 times 2 will be 4. So 4 plus 2 will be 6. That's why the total bonds directly attached to the E will be 6. So coordination number of E is 6. Now complex can be iodide as this: En whole twice C2O4 NO2, giving us En whole twice C2O4 positive plus NO2 negative. Now, if you find out the oxidation number from this ion, it will be X for E plus 0 for ethylene diamine plus minus 2 for the oxalate ligand will be equal to the total charge present on the complex, which is plus 1. For solve this equation for X will be equal to 3. So oxidation number is coming out as 3 and coordination number is 6. And thus our option D is the correct answer. Okay, let's move to the next question. Question number 6. The oxidation states of chromium in chromium hexaaqua chloride and chromium C6H6 whole twice and K2CrCN whole twice O2 NH3 respectively are. What we have to do? We have to find out the oxidation states of chromium in all these complexes. Options are +3 +4 and +6, +3 +2 and +4, +3 0 and +6, or +3 0 and +4. You have 10 seconds to solve this question. After that, we will see the answer. Let's see. The correct answer is option D, that is +3 0 and +4. So let the oxidation state of chromium will be X in all the cases. Let's find out in the first complex. X for chromium, H2 is having 0 oxidation state, so 6 times 0, plus chlorine is having -1 oxidation state, so 3 times -1 is equals to 0 because There is no charge on this overall formula. So solve for x, x will coming out as 3. In the second case, oxidation state of chromium is x for chromium, and for C6H6 it will be 0. So 2 times 0 is equal to 0. So x is coming out as 0. And in the third case, for K2 it will be 1. So 2 times 1 plus x for chromium minus 1 for Cn. So minus 1 times 2 plus oxygen has minus 2. So minus 2 times 2 plus O2 has oxidation state of 0. So 0 plus NH3 has oxidation state of 0 plus 0 is equals to 0. Solve for x, it will be 2 plus x minus 2 minus 4 is equals to 0, or x minus 4 is equals to 0. Hence, x is coming out as plus 4. So you can say that plus 3, 0 and plus 4 is the answer, as these are the three oxidation states we found in these three complexes of chromium. Thus, our D option is the correct answer. Okay, let's move to the next question. Question number 7. IUPAC name of platinum NH3 whole twice chlorine NO2 is. We have to find out the IUPAC name of this complex. Options are platinum diamine chloronitrite, chloronitrito N-amine platinum 2, diamine chlorido N platinum 2, or diamine chloronitrito N platinate 2. You have 10 seconds to solve this question. After that, we will see the answer. Let's see. The correct answer is option C, that is diamine chlorido N platinum 2. So this is the IUPAC name for the given compound. Okay. Amine, we have 2 molecules, so diamine. Chlorine, we have 1, so chlorido. NO2, we have 1, so chlorido. And platinum, N platinum. Second is the oxidation state, which we write for the platinum element in this complex. Okay. Thus, the C option is the correct answer. Okay, let's move on to the next question. Question number 8. Which among the following will be named as dibromidobis, ethylene diamine, chromium third bromide? We have given the IUPAC name of a complex. We have to find out the formula. Options are chromium En whole thrice Br3, chromium En whole twice Br2 Br, chromium En Br whole 4 negative, chromium En Br2 Br. You have 10 seconds to solve this question. After that, we will see the answer. Let's see. The correct answer is option B, that is chromium En whole twice Br2 Br. So 2 Br, as the name says, dibromido. Dibromido means 2 Br. 2 En, because we are using bis here. So bis is used for the 2 prefix. Okay. That means 2 molecules of, or 2 ligands, number of ligands of ethylene diamine is present. So 2 En and 1 chromium, because chromium is single. So 1 chromium are parts of the complex. So 2 bromine means minus 2 charge, 2 En means 0 charge, 1 Cr means plus 3 charge. We just balance it and find out. Thus, we can say that the complex cation will be chromium En whole twice Br2 whole twice positive. Right? And since the anion is bromide, because we have given the bromide here in the name, in the last of the name, right? That means in the last of the name, we always mention the anion name, right? So the anion is bromide, thus the complex will become CrEn whole twice Br2 square bracket Br, right? And thus B option is our correct answer. Okay. Thank you.